Let us see how to plot ILD for bending moment. So here if you see, I have taken a simply supported girder of a span L. So I am interested in plotting ILD for bending moment at C. Location C is at A, distance from left support. So let us see, a unit load is traveling from A to B. So if the load is at X distance from A, so portion AC, I am looking at it now. So portion AC, if you see, I need bending moment at C. So by definition, it is sum of all moments either to the left or to the right. So if I take sum of all moments to the left, I'll have two forces. One is unit load, the other one is reaction. So I'll go by bending moment to the right of this section, where you have only force RB into the distance is the L minus A. Okay. So RB from support reactions that we have seen earlier will be X by L. L minus A remain same. So this is bending moment at C when load occupy any position from A to C. Okay. So now to plot the values of bending moment at C when load is moving from A to C, when X is equal to 0, load occupies position A. In that case, bending moment at C will be 0 by substituting X is 0 into this equation. Then when X is equal to A, that means when load moves to point C, that means section. So bending moment at C will be A by L into L minus A. Right? So as you see, the values are increasing from 0 to A into L minus A by L. Okay, so that is regarding load moving from A to C. Similarly, for BC region, say I go with a different color to represent. I'll draw it again. In this case of load moving between C and B, section C here. So now place the load anywhere between C and B. That means it is at a distance X again, 1 unit, and the section remains at A, same as earlier. So the rest of the span L minus A. Now bending moment at C for the given position here, you see, by definition I need bending moment at C. It is by definition sum of all moments either to the right or to the left. So if I say bending moment to the right, I need two forces to consider. If I go by left, sum of all moments to the left of the section, I have only one force, that is RA. right? So it is RA into the distance is A. Okay. Now from the earlier discussion, RA you can write it like is L minus X, the distance of unit load from support B, L minus X by total span. So this is RA value. So now this is bending moment at C when load is occupying any position between C and B. Now when X is equal to A, the load is going to be at C, right? You see, when X is equal to A, load comes here. So in that case, bending moment at section will be, substitute X is A here, is L minus A into A divided by L. Okay. Then when load moves to the right end, that is support B, substituting X is equal to L in this equation will give you 0. Okay. So now as the load moves from section towards the support B, the bending moments are being reduced from A into L minus A by L to 0. Okay, so that is how it is going to. And now we are going to plot the diagram ILD. So I will take the reference line as x-axis to plot the position of load on x-axis and on y-axis to bending moment values at C. Okay. Now this is the section, location of the section considered. Between AC, this is the equation which governs the diagram, and the values are 0 at A, when X is 0, bending moment at C is 0, and when X is equal to A, bending moment at C is this value. So join this by straight line, right? And again, when X is equal to A, these two are, you can see the same values. These two are same values. Okay. So when X is A, bending moment at C is the same value as that of previous one. And from there, it is reducing to 0. When X is L, bending moment at C value is becoming 0. Right. Join these two by again straight line. So this value, this ordinate, maximum ordinate that you see, the value there is, it is L minus A into A divided by I. That is the maximum ordinate value. So this is ILD for bending moment at a section. Okay. So now if you observe that as the load moves from A, okay, the bending moment at C starts from 0. As load approach point C, bending moment at this point will become maximum. So means when load is exactly on the section, bending moment is maximum at this point. When load moves away from the section, bending moment at this point is going to reduce and become 0 when load reach here. So when load starts here, bending moment is 0 here. When load approach, bending moment is going to increase and become maximum. Then when load leaves from this place, bending moment is going to reduce and become 0 when this reach, the unit load reach point. Okay. So for maximum bending moment at a section, you shall place the load exactly on the section for maximum bending moment. So this is how you can read the ILD for bending moment. Okay, thank you.